Hello guys, this is Keshav Gupta. Today I'll be talking about the topic smart grid to you all about. I'll be discussing about the how the smart grid works and what are the components required in it. Like so we'll start with this. The smart grid is the revolutionary undertaking entailing with communication and control capabilities, energy sources, generation models, and the regulatory structures. The successful rollout of the smart grid will demand objective collaboration, integration, and, and the phenomenal array of disciplines. This includes the computational and communications control systems for generation, transmission, and distribution to customers and the different operations and helps in market and service provider section. So we'll start with the different domains of smart grid which we require for the establishment of smart grid. So these are the different domains of the smart grid. The first domain is generation and transmission and distribution and then customer participation and then operations, markets and service provider. The first we discuss about the generation. The generation is the main part of smart grid. These are there are various types of renewable and non-renewable generating technologies such as coal, hydro, nuclear, solar, biomass, geothermal, and different many more. So, operator has to coordinate the operation of generation plants and ensure the stable and secure operation to the system. Means they have to deliver it from generation plant to transmission plant like this, and then communication infrastructure needs to be placed in between generating facilities and the system operator, like electricity market and the transmission system. So we have to provide it to different markets like this. So now we move to the then next part of the system, that is the transmission component. The basically we need to transmission in the energy in the most efficient way. So the energy efficient transmission network will carry the power from the generation facilities to the power distribution systems. Communication interface must exist between the transmission network and the generating station. This will help the system operator to deliver the power to the customers and manage the power market, and then distribute it to the system. Then I will come about to, to the third component, that is distribution. The substation automation and distribution automation will be the key enablers of a smart distribution system. Increasing the use of distribution energy resources will be an important feature of future distribution system. Distribution system is the main component. We have to divide it, the energy we received, to the equally to the all sectors, different sectors like it is industrial sectors, residential sector, and different many more sectors. The fourth component is customers participation. The customers are the most important part of the smart grid domains. Like customers, these can be categorized into three categories like residential, commercial, and industrial. Building or home automation system will monitor and control the power consumption at the consumer premises in an intelligent way. There are different prices for all the three categories of the customers like residential, commercial, and industrial. There are different rates of the per unit consumption. So the next part is the operations. Smart grid operations require communication interface with the bulk generating facilities like and transmission system, substation, consumers, and the market. These are the main part because the operation has to collaborate with the all parts of the domains. It is the main part where the all the information is being provided and transferred to the different domains. Now, the next part is markets. Smart grid power market needs to develop and keeping in mind all the objectives of the smart grid, power efficient transmission, like these different objectives. The communication infrastructure integrating the bulk generation, transmission, distribution, consumers, market, and service providers is the key to the success of power market in a smart grid system. So the markets will provide you the customers and the different part of the and market will collaborate between the customers and the transmission powers. Right. The last part of the domain is service provider. Various service provider will emerge as the smart grid model matures. Communication interface with the operator, market, and consumers will be needed for the service provider. There are different examples of service providers like forecasting of renewable energy generation, billing and customer complaint management system, building and home management system. The next part is important part, the installation and commissioning services, the account management of the system, how much uh, per consumer they consume the electricity, of how much unit they consume per month, like different information about them. Now I'll move on. Now I will talk about the different advancement that is used in smart grid to help the system and to provide easy transmission and all this. So this is the basic electric system that will be initiated. Firstly, we'll be generating the power to the generating system, and then we transfer it to the step of transmission for the transmission purpose. There's transmission lines, though in which where different lines depending on the consumer demands, like 500 volt, 240, 345 volt, 230 volt, 138 volts, and the next is wire connecting to. Now we will have to step down the power of the system, the voltage of the system, to deliver it to the distance part. So a step down the subtransmission customer, primary customer, and secondary customer. These are different parts. Here, blue line represents transmission, green represents distribution, and black represents the generation. So now I'll talk about the first part, that is AMI. The AMI stands for the Advanced Metering Infrastructure. This is responsible for collecting all the data and information from loads and customers. This collects the all information from loads, like how much power is delivered and how much is received by the customer, so we can decide how much they consume per month. This is also responsible for implementing control signals and commands to perform necessary control actions. So first part is control and calibration. The control and calibration means the meter should be able to compensate the small variations in the control system. And the second is power management. In event of primary source of energy going down, the system should be able to maintain its functionality. Means the system should not be disturbed when the power is delivered. So we have to manage the power management system. AMI allows, the most important part is that AMI allows the user to better control their consumption pattern. It also offers higher power quality and stability. The next model is the next is a model that is deep learning loss model for large scale and low voltage smart grids. This is used for low voltage smart grids. This provides the information of distribution operating system control when distribution of system operators encounter the challenge of managing network losses in large geographical areas with hundreds of secondary substations and thousands of customers. This model provides a methodology to estimate power losses in large-scale, low-voltage smart grids. That is currently one of the main challenges that distribution system operators encounter is improving the energy efficiency of smart grids. This model on implementation shows the aggregate power generation from each representative feeder. and provides the different power management graphs and how much they consume, how much they use, and where they use the power, how much are the losses. So the next part will move on to the low voltage power grid congestion reduction. How to reduce the power congestion? The first method is by installing a battery storage system in the power grid. This helps distribution network operators congestion problem caused by decentralized renewable generation. The more potential solution for this problem is the community battery system. The problem is solution to the problem is congestion control by using energy storage. By locally storing the energy generated by the solar power installation, the voltage and the current in the low voltage network can be kept within the desired bounds. The most common version of this solution is a home battery system, but home battery system is not much more reliable. It is more efficient to use a community battery since the home batteries are often not fully utilized. Community battery also requires less space and can be serviced more efficiently. So this is the proposed image of the community battery. Here the community battery is installed, then the power is delivered to the every and each house or the consumer to this power network feeder cable. The community battery delivers to every house the power, and this way this storage battery work. The next model and the next is the fault diagnosis in the low voltage smart grid systems. This uses a gradient based boosting tree model to detect and identify and localize single phase to ground and three phase faults in low voltage smart grid distribution. The two widely used fault location methods are impedance based and traveling wave methods. Impedance based methods, although being the mostly widely used method for fault location and applications, they have a big problem when using them. There is a underlying risk of identifying multiple faults locations belonging to different branches, but the same distance from the beginning of the feeder. While traveling methods have a higher accuracy, they also present several disadvantages. They rely on detection of wavehead and sometimes can be quite challenging. They depend on the line parameters, which on distribution systems vary a lot since the speed of the wave is based on inductance and the capacitance of the lines. They are vulnerable to external signal interference. The main advantage of the gradient boosting tree is its very fast estimation, which in turn makes the implementation implementable in real life applications. So it is the very fast model that we can use here. The next is the over voltage protection in the low voltage networks. So this is used in the period of those thunderstorms. The number of failures in the thunderstorms, the number of failures of electrical and electronic devices increases. The main reason for these failures is over voltage in the wiring system that is caused by atmospheric discharges. Happens in the thunderstorm, the due to lightning and different parts, the over voltage is varied by those, and we have to use a efficient system to control this. So, in order to protect against such failures that also cause material damage, facilities should be equipped with lightning protection system and quality over voltage protection. A model of an over voltage protection system was developed consisting of models of surge wave source, line, low voltage line, hammer surge arrestor, and a gauge discharge arrestor. The computation research showed that the impedance of the low voltage line influenced the operation of the over voltage protection system, especially the operation of the gauge discharge arrestor regarding its ability to self-extinguish. So it will allow the gas to extinguish from the system, and this prevents the from over voltage and protects the different devices. So these are the there are many activities started related to smart grid in India. So the first activity is India Smart Grid Forum, that is defined as ISGF. This is launched by Union Power Ministry on 26 May 2010. It is a non-profit voluntary consortium of public and private stakeholders with the prime objective of accelerating development of smart grid technology in the Indian power sector. This is the first time when the smart grid forum is launched to enhance the different technologies smart grid and improve its qualities. The second is India Smart Grid Task Force. It is an internal interministerial group and this serves as government's focal point of activities related to smart grid in India, distributed control, and self-healing of the grid following a disturbance. And many different utilities have started individual activities at different levels connected to smart grid. Several pilot city projects are being funded by member of parliaments and coordinated by Ministry of Education. There are various programs that are running under the Indian government to the enhancement of the smart grid and to improve the power quality of the system. So these are the conclusions that I have drawn from this my research on this. So I have researched on I read aloud around 10 to 12 research papers about related to smart grid and the different articles related to smart grid on all the materials available on the Google and related to smart grid. I read about it and I have drawn these conclusions. Smart grid is characterized by the integration of communication network and IT infrastructure with the power and energy layer. With these are the main parts where the communication networks we have to communicate through the different components of the smart grid like transmission, generation, customer, and the market. So we need then IT infrastructure which will manage all these and collects data from all these departments. It requires a seamless integration of different types of bulk energy sources, distribution energy sources, trans- transmission and distribution system, communication systems, and measurement system. So there should be an integration between all these systems. Without an integration, the system will not all the components, the system will not work. With all the components, they should integrate properly among themselves to a better smart grid management. Managing the large amount of information and ensuring its security will be a big challenge. The cybersecurity and cloud computing applications are bound to get increased importance. So here comes the main part, the security. When we are providing the customers this power, we have to manage its security that their data are not leaked, their information is not leaked. So it is the main importance of cyber security and cloud computing application that they secure our data and provide a good power to the consumers. So thank you for watching this video. This is my first video on the smart grid. Thank you.